Hey everybody, this is Larry. This is me doing Q4 of the weekly counters for 76 count stable subarrays. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one is actually not super bad. I think I've seen a lot of like segment tree solutions and binary index tree solutions, which maybe there's a way to do it that way. I mean, there definitely is a way to do it that way, but I did not do it that way, and I did with more fundamental stuff. And I'm just waiting for my thing to load. But the first idea is that, okay, given a list of numbers, right? It's all about runs, right? So here you have, let's just say you have 2, 3, 4, I don't know, 2 again, 5, 6, 7, whatever, right? And then now you know that there's a streak of 3, you have a streak of 4. So then what does that mean, right? Well, this streak of 3 means that you have one subarray that ends on this one. You have two subarrays that's at this one, 3, right? So 1, 2, 3, 4, right? So then, of course, now if you always end at the boundary of these things, of these groups, then now this would be easy, right? Because then now you just do a prefix sum, and that's what I did. And prefix sum is fine because this is relatively static. Right, everything is static after the initial processing, right? So then now you do a prefix sum to get, some of these numbers, and that'll be fine. The only issue is that when you are crossing boundaries, for example, if your query goes like this, then what happens? How do I change the color of it? Okay, I lied though. But let's say you're doing a query that goes to let's just say this for now, right? Well, the thing is that you cannot just sum up you could sum up 1, 2, 3, 4, and that's fine, but you cannot just sum up 3, right? Because this, it represents this number which only has a 1, right? So there are a couple of ways you can do about this. What I did in essence is that and maybe I should have done this in code a little bit cleaner because that's why I got 2 wrong answers. But the idea then now is just becoming, well, yeah, if you have, you can kind of think of it now then as just, you have a lot of prefix sums, right? Let me actually rewrite this. Because then now you can rethink about this as having, a lot of streaks of stuff, right? So you have one streak, another longer streak, another streak, and another streak, right? And then the idea here is that now your queries say, I don't know, like say this chunk, then what happens? Well, here you can just use regular prefix sum to get the sum of all these things, right? And then in the same way, now you just have to kind of keep either add in or subtract back out the little things that are here and here. And that's fine, and that's it. That's mostly the critical part of the solution, because then now, if you do this prefix sum, you can say and do O of 1 or even O of log n. It doesn't really matter. It doesn't matter because it gets dominated by, let's just say these two parts are also log n. Then you are fine, right? And that's kind of the entire. I mean, this isn't the entire solution, but this is kind of the idea behind the solution. That the structure that allows you to build toward the solution, right? And that also becomes oops, what did I click on? That of course still depends on the recognition that the streaks is the important part about this problem, right? Okay, so then I think like something's wrong with my keyboard. Or maybe I just keep hitting it by accident. But yeah, so that's basically the idea, and that's basically what I have. If I can click on this. Nope. What's my computer doing? But yeah, basically the way implementation-wise that I did was that I have this I have this run thing, right? So then we're able to do the prefix sum on it later. This is where we talk about the 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, and then just do a prefix sum over all that to get you the sub thing. And then here, on the actual answer, we also keep track of the segments, right? So that we can do the segments on the before and after. The key thing about that is mostly that everything, it's only based on length, right? So I know that I did say some stuff about, you know, prefix sum here, right? Which is fine. But here, actually, for this part rather, the only thing that matters is the length, right? Because given a length, then you just have 1 plus 2 plus 3 plus dot 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 plus L, which, you know, the formula to, hopefully, which is L times L plus 1 over 2, right? So, and you could do that all, you know, pretty straightforward way, and that's basically what I did, right? I keep track of the segments of, you know, the streaks, and yeah, and I do a binary search. I do this math here to add it back in if it's not added. Yeah, and that's it. And on the prefix sum, also binary search so that I cut off on the right side of this. So that I have this basically. Yeah. So I cut off on the right side. Well, actually, it's a little bit different actually. I think I lied on this visualization a little bit. The thing with this is that because the way that prefix sum works, I can actually on the right side I can actually do prefix sum just up to here, right? Because here, let's say this is, because, you know, this is 1 plus 2 plus dot 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 up to the number, so that should still work. And that's basically what I did for the right side. And then the left side I do the binary search and what you see here. So I kind of lied a little bit inaccurate about that. But yeah, but that's why I do a binary search. I cut it off on the right side, and then I add it back in on the left side with the binary search. I think I'm going a little bit fast, but you know, you have the power of time on your hand. Go through the code, see what the binary search gives you, and yeah, let me know in the comments. This is linear time, linear space, right, for this part, right, for the all the way up to the prefix sum. We have binary search per query, so each query is going to be log n. We have q queries, it's going to be O of n plus q log n. And that's it. That's all we have for this one. Let me know what you think. Thanks for watching. I think the I mean, I don't know. The implementation is fine. It's not easy. It's not too bad if you ask me either. But I think the core part about this is just understanding how to break this problem into smaller problems. And yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve a live in the contest now. I should have done that to begin with. I was taking too much time trying to play around with other ideas. Okay. Count stable subarrays. How am I doing on time? By now they should remove all the cheaters, right? Oh, people did Q3 fast, but okay. People did Q4 fast too. So okay, let's take a look. You have nums, subarray of nums equals stable if there's no inversion. Okay, you have 2D queries, okay. Number of stable subarrays that are inside it. Okay. So 0, 1. 1, 2. Huh. I don't know if I know how to do this one off my head. No inversions. Meaning that this is sorted, right? So then now what? I feel like this is like a weird segment tree thing. Well, it's not that it's sorted, but it's just the runs, right? So you have to kind of keep the streak of the longest things and then sum them up kind of thing, right? So it's basically, yeah. And you have to subtract them in like a prefix sum kind of way, maybe? That sounds maybe right. Right? This 3 is 1, this is 1, so this is 2. 1 and 2, okay, so this is gonna be 1, this is 2. Which is fine, so then that returns 3. 0, 2, this is going to be 1, 1, 2, which is going to be 4. the thing is that it may cut off, so you have to kind of handle that. Whew. Alright, I'm gonna use the bathroom real quick. Man, I ate too much burrito beans. Okay, maybe I could tough it out. Let's see. This may be a little bit of a weird video, but okay. Okay, I think I know how to do it. But okay, that's at least this makes sense that people did it so quickly. Yeah, okay. It doesn't matter. What? That's what I expect. Though this should be equal, so okay. 1, 1, 2, right? And now we just do a prefix sum, right? And then now, yeah. Is it? It's not quite right, I don't think. I mean, it is kind of right, but it's not. Maybe this is just like a default segment tree problem, but which I don't know it because you have to get cut off. That's the thing, right? You can't just do. I mean, this will. I think this actually works for the input, but I think this is wrong because we'll do a case right now. I don't know why my computer's a little laggy right now, actually. Yeah, so this is actually right for the input, but I think this is wrong. You have something like 2, and then maybe just, I don't know, last one, right? And it should be 1, but I may return 5 or something, right? How do I get rid of it? Right, this I'm going to use the restroom time, and I'll think in my head. Huh. I have to figure out. Yeah, I don't know. You have to figure out how long it extends, right? Sorry, I'm still talking into it. Let's see. Let me take a look at the constraints real quick. Okay, double checking constraints. Because I have to know when it ends, when it starts. Yeah, I don't think it's that hard. I think it's just have to be bookkeeping, keeping track of the left side and the right side, right? So then now it's about figuring out the sum of the things, right? Because if it's 5, or maybe just doing the math, maybe. No, because you don't know how long it goes, so you do have to keep track of when the run ends, right? Yeah, I mean, it's just annoying. It's not a big deal. Okay. Like that. But we actually want to know when it ends, not the start. But for now, we are good. Well, I guess when it ends, we just do it backwards. I guess that's fine. We could even do smaller than that, actually. We can just do a segment thing, right? Maybe something like that. Oh yeah, and then this should be n, I suppose. Is it inclusive? I guess so. So n minus 1, fine. Okay, right. Because then now we can do a binary search on it. No, that's the index. That's a sig RL. Something like this, right? Let's see. It should give me 0, hopefully, but it's not. Why? What is RL? Because RL. It's out bounds. It's out bounds, then. Oh, yeah, then R is fine. Something like that, so still all right. But then now we have to add back this thing, right? Is this even right? No, it's right. For the first two, I mean. Okay, and then now we have to add back. So okay. So it's here. So this looks at the now is the previous one, right? So then it's RL. this one doesn't matter anymore. And then now it is going to be the actual L. So then length is equal to actual L minus this thing, right? And then just something like that, right? Something like that. Maybe not. This goes out, so it's 0. So then this is going to be 4. We have 4, 4. So then, oh, it's this plus 1 is the length. Almost clicked on submit by accident. Okay, but now this is wrong. Why is that wrong? Oh, because this matches exactly, I think. So then it doesn't need it anymore. This is 1, 2. So this is this. It matches exactly. Then if for some reason I guess it just takes 3. Okay, let's just look at. Let's print this out real quick. Right, so it's 0, 4. Oh, cause no. This is not the wrong one. This is the wrong one. Okay, so then now it finds 1, 2, fits perfectly, but now 0, 0, 0. Okay, but then why? We got like double negative things going on. L is 2, L is 1. This is wrong anyway then, right? Because this should be, we assume this is going to be this. Okay, so now this is good. I don't know how I just got lucky with the other one. It's not great though. Alright, I'm not super confident honestly, but I am ready to YOLO. I think this is roughly the right idea. Maybe it's wrong. I mean, there's a lot of easy wrong mistakes I can make. Wouldn't be surprised at all. But yeah. Well, I am ready to give in. This is weird. Why did I 3, 3 then? I mean, yeah. I thought I mean, this is what I was trying to do with my case, but I suppose I didn't check it fully enough. Because if I did, then I would have seen that this is wrong. This is very wrong. Right? Why is this very wrong? I mean, the idea is right, but my implementation's a little bit off. Clearly, I think we're on the right track. It should be able to fix it. But okay. So it is not. So what happens? So it's definitely this part, right? 3, 0. Okay, so it tries to search for 2 on 0, 3. It goes out of bounds, so then now -1. So it's this. Oh, because I didn't bound it on the right side. I bound it on the left side. It could also be the length is just wrong because this is going to be min of this and R. Okay. If that's the case, that's an easy fix. I mean, I already fixed it, right? Hopefully that's it. And no more silly mistakes. That's a pretty bad. Okay, well, negative numbers is also pretty bad, but also easy to debug in theory, but that's still not great. Okay. 1, 1 is -2. This is 0 base, okay. Why? So this thing? Oops. Let's see. 1, 1, 0, 2. Right? How do I get -2? I already have negative here. from the previous part. Okay, so this is actually wrong on this part. Is it going to that port? Why is it going to that port? 1102 should go out of bounds, right? So this should not hit this. Do I not reset current? No, I reset current. Huh? Yeah, this is out of bounds, which I actually expect, right? Maybe. I missed something. But why? I don't get it. Oh, I don't get why this is doing this. Oh, L is 1? Isn't the line, the segment? Shouldn't this be only one segment? Oh, this is a 10. I misread this entire time. But okay. So then now it goes here. Now we're searching for 1 is here. Okay, I mean this is the same thing as this, but on this part, I think, right? So okay, so that's basically why. So we're inside a segment, which I think this handle no. 1 goes here. Whatever, just write like that should be enough, right? Looks okay, enough. Hopefully. Okay, so a lot of silly mistakes, but the idea was right. I mean, I only really needed to add this check and this check and this check, I suppose. I think I already had this one, but yeah, I mean. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about today's farm. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.